Hello everyone, welcome to my channel. Today we are going to discuss about 3D printing of ear. So far we discussed about what is bioprinting, what is 3D bioprinting, and we also discussed about materials used for the 3D bioprinting and the techniques which are used for the bioprinting. We have discussed about inkjet technique, okay, and many other techniques we discussed in the previous, I guess 5 techniques we discussed in the previous class. So today we'll start with the 3D printing of ear. So 3D printing has revolutionized the field of the medicine, and one of its application is the 3D printing of human ears. So as we discussed in the introduction and this thing, we have I had mentioned 3D printing applications and all. In that, specifically for human ear, okay, so it has given a lot of contribution, okay, the ear formation. That's why I was keep on giving the ear example in the previous class. So this process involves using a 3D printer to create a ear shaped structure using special material, okay. So that special material should be biocompatible. For example, polymer hydrogel as a ink. So now we know to print what we need ink, right? So this ink is nothing but whatever the material is required to print this thing, right? So here we are using the 3D printer, which will have the ink, which will compose of biocompatible materials such as polymers, hydrogel as ink. Okay, so now this particular shape or a structure is designed, and based on that it will be printed. So now the printed ear structure is then seeded with the human cartilage cells, okay, which grow and develop into a functional ear tissue over time. So after printing the structure, now the only structure is ready, but cells need to be seeded. Okay, the ink will be seeded. Cells will be seeded along with this particular printed ink, so that the functional cells will start growing. It will form a tissue, and finally you will get the required organ. So this is exactly how it looks like. This is the usually we will use for design computer generated model, for example CAD and all. So it will first design, it will have a design what to print, how it should look like, what are the dimensions, or where exactly the curvature should be there, what angle there should be a curvature, and how exactly we should get the ear. Okay, all that design should be done by computer. It's all computerized by using certain softwares. You can have a 3D bioprinted organ structure here. This is a structure, and this is the finish, design, what you can say, and this is the product after finishing the work, or you can say the process, or the final product should look like this. Okay, that means it should follow the whatever 3-dimensional bioprinted organ network, or the design which is prepared by the computer. Understood? Because this design, it depends on where, how many pores should be there inside this, and whether the tissue should be soft or hard, or whether the structure that is this, what is the network kind of structure you are seeing now, this is nothing but extracellular matrix, which will give you the proper shape of the ear or any organ. So all those things will be mentioned in the design. So based on that only printing will happen, and if that happens, and if you make sure that nothing goes wrong, and you will be probably getting 99%, and I guess in most of the times 100%, you will be getting the same structure what you have designed. So that can be implanted very easily, so that there is no abnormality in the ears anymore. So usually why we go for ear transplantation? If any abnormalities is there, for example, when the baby by birth only, some people will be having the deformed ear. Like means ear is not the proper, but it is some kind of either it is either it is small, or either it is too small, or either it is deformed like this, or some kind of structures will be there, so which is not normal. So during all these things we can go for this particular organ transplant, or even in some cases in the cases of accidents, or in the cases of any, what you say, the fight, that, this stuff, and whoever loses their ear, or the structure of the half of the structure ear is being cut, so there we can use, so that it can be the proper ear can be replaced by using this particular 3D bioprinting technology. So the main advantage of 3D printing an ear is that it allows for the creation of an ear, so that is a custom fitted to individual patient, which is based on their specific ear shape and size. So what is the main advantage of this particular technology is that our ear is there, we can customize it. For example, imagine a person who lost his one particular ear, right? Or he has got a deformation in a ear. Now you need to make one ear for him. So what you cannot simply have one ear which is there, which you can produce in a large scale and put it for everyone. You cannot do that. That also can be done, but in this particular 3D printing technology, the one application, one advantage is that every person is not having the same size of the ear, right? So someone's ears are small, someone's ears are big, right? So like that. In peak you can see Amir Khan's ear became like almost like elephant ear. So those kind of situations will be there. So you can measure the such particular his another side ear, all the dimension. You copy the design and you print this thing. Okay. So ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ. ಸೊ ಇನ್ ದಿಸ್ ಹಿಯರ್ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ರೆ ಎಲ್ಲ ಇಂಟ್ರೊಡಕ್ಷನ್ ಅಬೌಟ್ ನೀನು ಏನು ಹೇಳಿದ್ವಿ ಅದೇ ಕಿವಿಯಿಂದ ನಾವು ಮಾಡಬೇಕು, ಅದಕ್ಕೆ ಮಾಡೋಕ್ಕೆ ಏನೆಲ್ಲ ಬೇಕು ಅದನ್ನೇ ಹೇಳ್ತಾ ಇರೋದು ಇಲ್ಲಿ. ಓಕೆನಾ? ಸೊ ಪ್ರೊಸೆಸ್ ಅನ್ನು ಮಾತ್ರ ನಾನು ಕನ್ನಡದಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ, ಇವೆಲ್ಲ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಬೇಕು. ಸೊ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ಸ್ಪೆಸಿಫಿಕಲಿ ಯೂಸ್ಫುಲ್ ಫಾರ್ ಚಿಲ್ಡ್ರನ್ ವಿತ್ congenital ear deformities or individual who have suffered ear injuries or losses. That's what we told. So if any congenital ear deformations are there like that by birth, if any deformation in the ears are like there, especially for children and all, we can replace that. Or if any injury, because of the injuries or because of some other issues, if the person loses its ear, for him also we can go for it. Next, additionally, 3D printing can also be used to create ears, okay, that are anatomically and functionally similar to the patient's normal ear. That means we are copying this normal ear, and if this is not normal, copy this and make a normal ear for here. That's it. Okay. So these are some of the materials which we use for the particular technique. It depends on the specific techniques whatever you are using. Based on the technique, the materials will be decided. So the first one is hydrogels, biocompatible polymers, scaffolds, cell embedded materials, and ceramics. So personalized technological importance of 3D printing. So here what we can do, the technologically what we can do is, so we can give a particular importance to the specification. For example, personalized ear prosthesis. That means, as I just told you, for every person has got their own, different size kind of structure. So we can customize it. Customize means we can manipulate it. We can have a bigger ear, smaller ear. Customize ಅಂದ್ರೆ ಒಂದು ಸಣ್ಣದು ಅಥವಾ ದೊಡ್ಡದು, ಬಟ್ ಹೇಗೆ ಮನುಷ್ಯರದ್ದು ಕಿವಿ ಈ ಕಡೆದಿದೆಯಾ ನಾರ್ಮಲ್ ಕಿವಿ ಇದೆ ಅದೇ ತರದ್ದು ಈ ಕಡೆದ ಇರಬೇಕು. ಸುಮ್ಮನೆ ಒಟ್ರಾಶಿ ಎಲ್ರಿಗೂ ಒಂದೇ ಕಿವಿ ಇದು ಮಾಡಕ್ ಆಗಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಹೇಳಿದ್ರು ಕಸ್ಟಮೈಸ್ಡ್ ಇಯರ್, ಎಲ್ಲರದ್ದು ಬೇರೆ ಬೇರೆ ಸೈಜ್ ಇರುತ್ತೆ, ಅದರ ಪ್ರಕಾರ ನಮಗೆ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್. ಸೊ ವಿ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಎನಿ anatomy of each patient. Next, faster production and lower cost. So traditional methods of ear prosthetic fabrications can provide a time consuming and inexpensive. So that's why we can go for the bioprinting, so that it can be faster production and low cost. And 3D printing can reduce the production time and also cost of ear prosthesis. So, okay. Next, biocompatibility. So the next third importance of 3D printing is that it's biocompatibility. So we can have the materials. In the material selection in the yesterday's class we discussed, no, it should be biocompatible, biodegradable stuff. So this 3D printing can use biocompatible materials for the production of ear prosthesis. Okay, that prosthesis in the sense whatever we get as an organ or any tissue, okay, as a product. ಓಕೆನಾ. ಪ್ರೊಸ್ಥೆಸಿಸ್ ಅಂದ್ರೆ ಈಗ ನಾವು ಕಿವಿ ಪ್ರಿಂಟ್ ಮಾಡಿದ ಮೇಲೆ ಅದೇನು ನಮ್ಮ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತಲ್ಲ ಅದನ್ನ ನಾವು ಪ್ರೊಸ್ಥೆಸಿಸ್ ಅಂತೀವಿ. ಈಗ ಲೆಗ್ ಇಂಪ್ಲಾಂಟ್ ಕಾಲಿಗೆಲ್ಲ ಹಾಕ್ತಿವಲ್ಲ ಅದೆಲ್ಲ ಲೆಗ್ ಪ್ರೊಸ್ಥೆಸಿಸ್ ಅಂತೆಲ್ಲ ಕರಿತೀವಿ. ಓಕೆನಾ. ಸೊ 3D printing can use the biocompatible materials for the production of ear prosthesis, reducing the risk of adverse reactions and improving the patient's outcome. So biocompatibility ಅಂದ್ರೆ ಏನು, ಅಲ್ಲಿ ಹಾಕಿದ ಮೇಲೆ it should not be it should not produce any adverse reactions. Okay, and it should also improve the patient's outcome. Okay, now so next, medical education. So 3D printing of human ears can be used to educate medical students. Okay, so you can have the three-dimensional structure, networking with the softwares, this and all. We can educate the medical student and healthcare professionals on anatomy and as well as treatment of ear defects and injuries. So we can have the proper anatomy study, and then we can also go for how the treatment can be done for ear defects and injuries. ಸೊ ಇಲ್ಲಿ ಏನು ಮಾಡ್ಬೋದು ಅಂದರೆ ಮೆಡಿಕಲ್ ಎಜುಕೇಶನ್ ಕೊಡ್ಬೋದು ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಬೈ 3D ಪ್ರಿಂಟಿಂಗ್ ಟೆಕ್ನಾಲಜಿ ಯೂಸ್ ಮಾಡಿ. ಅದರದ್ದು ಅನಾಟಮಿ ಅಂದರೆ ಅದು ಹೇಗೆ ಕಾಣುತ್ತೆ, ಅನಾಟಮಿ ಅಂದರೆ ಫಿಸಿಕಲ್ ಸ್ಟ್ರಕ್ಚರ್, ಅದು ಹೇಗೆ ಕಾಣುತ್ತೆ ಅದ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೋದು. ಅಂದರೆ ಅವರಿಗೆ ಜಾಸ್ತಿ ಐಡಿಯಾ ಕೊಡ್ಬೋದು, ಅಥವಾ ಡಿಫೆಕ್ಟ್ಸ್ ಅದಕ್ಕೆ ನಾವು ಟ್ರೀಟ್ಮೆಂಟ್ ಮಾಡೋದು ಹೇಗೆಲ್ಲ ಮಾಡ್ಬೋದು ಅನ್ನೋದನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೋದು. So that was about technological importance of the 3D printing of human ear. There are four importances: personalized ear prosthesis, we can customize for a specific person; faster production and lower cost, we can have faster production since all the whole starting to end in one process only printing will be there, so it also reduces the cost. The third one is biocompatible, make sure that there is no adverse effects, and fourth one is education purpose for medical students. So that's it about the 3D printing of the ear. Okay, so here 3D printing, the process is as a general approach what we discussed. Here we can just go through. So this particular, the formation of this particular design is very important. Once the materials, first material selection, general approach only you can write here. Okay, so material selection, then you do the design properly, and then make sure that all the ink is prepared. It means whatever need to be put there, cells, it can be biomaterials, biomolecules, and and extracellular matrix. Now this extracellular matrix, you put all those things and you keep it for incubation so that it will form this particular final product. Okay, so that's